rules are not exhaustive. Exhaustive means maybe few records maybe might left which are not meeting any of the rule. So in that case, we will create one default class. Okay, for example, uh, as we discussed in our last lecture, that there was one, what I can say, dogfish. Yes, right. So dogfish example was there. It might be here also. Yes. So here you can see dogfish. So it is not meeting R1, R2, R3, R4, R5. It is not meeting any of the rules. So in that case, we have to create one default uh, rule which will get surely triggered for this. Okay. So if any of the record is there which is not meeting any of the rule, in that case we will create one more default, you know, rule which we know will get surely triggered. Okay. So in ordered rule set, rules will be ordered in according to the priority. Okay. So this rule ordering scheme are based on, one is based on rule orders and second one is based on classes. So what does this rule order says, that according to their priority or according to the rank, okay, rank can be calculated on the basis of priority. So according to the priority, rules will be written. So if you will observe here, rule in first box, okay. So in this rule based ordering, refund is if refund is yes, then uh, class label is no. Second rule, third rule, fourth rule. All right. So first one is having more priority, second is having less than that, third one is having less than that, and fourth one is the least priority one. So we have ordered the rules in this way. So whenever any new record will come, first we will check according to first record, then second, then third, and then sorry, first rule, then second rule, then third, and then fourth. All right. But in class based ordering, what we will do, for example, let's take example that if we wanted to classify for mammal, okay, so either that particular record will be mammal or not, so yes or no. So initially I will group all the records which are giving result for yes. Okay, so here they have collected everything for no. So if you will observe in class based ordering, first, second and third, all three rules are giving result for no, no class. Fourth one is giving result for yes. So in this way, we can keep the rules according to the either rule priority or class. Okay. So if we have to, build classification rules, if we want to develop a model, then there are two methods. One is direct method, another one is indirect method. Okay. So under this direct method, what happens? We will be extracting the rules from dataset. Okay. So we will be creating uh, first, first rule, then second rule, then third rule. In this way we can do. But in indirect method, what we will do, we will extract the rule with the help of other classification model, such as a new, decision tree, neural network. How? For example, with the help of your ID3 algorithm, you have got decision tree. Now, with the help of that decision tree, rules will be extracted for your classifier. Okay, so it is indirect method. So under this direct method, sequential covering algorithm comes. Okay, so initially there will, empty rule set will be there, and then in every iteration we will, add rule one by one with the help of learn one rule function. Okay, we will discuss about it. And when this learn one rule function, and this learn one rule will, when you call it first time it will give you one rule, when you call it second time it will give you another rule. So at one time this call will give you only one rule. Okay, so the rule which you have got, and all the records which have been covered with that rule, all those records will be removed by your dataset so that you can continue. Okay, and in this way you will keep continuing until and unless your record set becomes empty, and in such a way that all the rules which have been made are covering the records. Okay, so this example I will show later. So how your rules will grow. So your first thing is that your learn one rule function will be extracting the classification rules which will be covering most of the positive examples. Okay, we will start with the positive example, and very few of the negative examples will be covered with those rules. But if you want to find the optimal rule, okay, as the record size might be exponential and every iteration we have to go through all those, so it will become very complex. But with the help of this learn one rule function, this exponential search problem will also get addressed. How? Because it works in greedy fashion. Okay, so initially it will generate one rule, and it will keep refining that rule until and unless stopping criteria will be met. Okay, and whatever rule we have found, it will get pruned also so that your generalization error will be reduced. So there are two strategies for growing any particular classification rule. One is based on general to specific, and another one is based on specific to general. Okay, so under this general to specific, what will happen? Let's take our previous example where we have to find whether it is a mammal or not. Okay, I know this is my end target. Okay, I have to find all those rules which will be helping me in finding the mammals. But right now I don't know how to do. So I will make one empty rule. Okay, so my rule will be like one empty rule which is deriving the class label which I want. I want mammal. I know that the class label should be mammal. I have to derive the rules in such a way. Now we know there are various methods, right? So let's go to our data set. Here. So if you will observe that this example, blood type gives birth, can fly, live in water. Such type of things are there, right? So we know that if blood type is warm, see, if blood type is cold, then it is never going to be a mammal. So, and I don't know what else will be true. So I will say blood type is warm. But again, this is not the final one. Why? Because it might be having few cases where other than mammals are also getting covered. Let's check. Blood type is warm. First one is mammal. Blood type is cold. Third. For whale, blood type is warm. It is a mammal. For bat, blood type is warm. It is a mammal. For pigeon, blood type is warm. It is a bird. See, other than mammal also, few more cases are getting covered in this condition. So I know, but I know that with this rule, I am getting my output, but few more additional things are also coming. So I have to remove this. But in first case, I don't know how to do that. And along with this, we can check other things also. Gives birth or not. So for that also we can check. Can fly or not. So can fly. If it is no, then you can prune. Okay, so there are various methods where you can find it. Now, but again, you will be checking their performance, okay, and whoever is getting more performance, parameters quality, that will get continued. So if blood type is warm, now we saw that few other than that few more cases are getting covered. I have to refine it more. Okay, I have to refine it more. So if blood type is warm, along with this I will add gives birth. If it is yes, it is mammal. If it is yes, it is mammal. If it is yes, it is mammal. For cat it is yes, it is mammal. For penguin it is no. For crane it is yes, it is mammal. For dolphin it is no, it is mammal. Okay. So I know if I add this gives birth, okay, along with this, so blood type is warm and gives birth is yes, then it is mammal. Okay. Similarly, blood type is warm and does not fly is no, then mammal. But again, it will get to. But here, if you will observe this rule, you will find out that what has happened here. All the cases, all the records which are getting compared with this rule are always mammal. There is no other noise. So I will say this is the first rule which I got. Okay. So what happened here? I took general. Okay, I did not know what is the left hand side, and I got specific. Okay, so in this way we can continue. Now one more approach is there where we will start with the specific one. So let's take example. So in that case, what we will do, if I want for mammal, so I will take any record which is resulting in mammal. So let's take first example where human. So now I will take all the attributes. So I will make one node where condition will be like blood type is warm, gives birth yes, can fly no, live in water no, then class is mammal. So what will I do? I will start with the specific. In that case, I will take one example. Any random record where our condition is true, blood type is warm, gives birth yes, fly no, and lives in water no, then it is a mammal. Okay, but is it really needed? So what we will do? Okay, so what we will do? We have to prune it. Okay, maybe few additional things are there, and maybe these conditions are not true for all the mammals. Maybe, see, I have made it so much generic. See here, mm, like this. Okay, can fly no, can live in water no. Okay, now let's take example of bat. Blood type is warm, gives birth yes, but can fly. See, here it is yes, and live in water is definitely no, but can fly is yes. Similarly, few more cases can come for whale, right? Let's check for whale. Where was whale? Hmm. Lives in water, yes, but again it is a mammal. See, again, if I will give some condition like this, it is becoming more specific, and maybe we are missing few cases. So in that case, what will happen? One by one, in one case, I will remove this condition can fly one, and in another case, I will remove this condition lives in water, and then again I will prune. So I will get the final one where only two conditions will be there: gives birth, blood type is warm, gives birth yes. So I will say this is my rule. So here what happened? I went from specific, okay, where rule was done for a specific record to the general. So in this way also we can find the rules. All right. So how this sequential covering algorithm works? Initially, if you will observe this example, there are few positive examples in your data set, few negative examples. Okay. Now you have to get a rule which is covering most of the positive, I can say records. Okay. So what did I say? Uh, Here, one, two, three, four, five. Five records are altogether positive. So maybe little bit difference will be there in their properties. 4 and 4. So I know I have to find a record which will be covering these five examples. So let's assume in this step one, if you will, in first figure it is original data. In first step, it is showing one dotted box over this. It is showing that the rule which I have finalized in step one is covering these five examples. So I will say that this is covered by rule 1, and we know all the records which have been covered by rule 1 will be deleted from the record so that we don't find a rule covering those. Okay, so we have replaced it by R1. Now I have found one more rule which is covering this cluster setting 1 in step 2. I will replace it with the help of R2. Similarly, in step 3, I have got R3. So in this way, step by step, I have got the what I can say rules. So how your sequential algorithm works? Initially, rule set will be empty. Okay. Then with the help of learn one rule function, we will get one rule. Then we will remove all the training records from our data set, which are covered by our rule 1. And then I will add that rule to the bottom of our rule list. Okay. So I will maintain one rule list. So one by one in all the iterations, we will keep doing it until and unless my record set becomes empty. Okay. So in this way we can do. Now we have to prune our rules. Maybe the rule which we have got is more specific, or maybe with less conditions also same result we can get. So for that also we can do the rule pruning. So that under this direct method sorry, we have Ripper algorithm. Okay. So how this Ripper algorithm works, it will start it works similar to the sequential algorithm. It will start from empty rule. Okay. Conjuncts. What is conjunct? In left hand side, A1 and B1 and something, all the conditions are, so every part is called as the conjunct. So add conjunct as long as they improve Foyle's information gain. There is one parameter called as Foyle's information gain. Stop rule when rule no longer covers negative examples. Okay. Prune the rule immediately using incremental reduced error pruning. Sorry. And how this measure will be how pruning will be measured with the help of this example. Number of examples covered by the rule in the validation set. Number of negative examples covered by the rule in the negative. Delete any final sequence of the condition. So I will show you with the help of an example. First, I will just show you how one rule, you have got that function, one rule function, right? The learn one rule function, it is based on that. Under that, Foyle's information gain. In that example, what did I tell you? Maybe we will be using accuracy or some other parameter, but in Ripper we have Foyle's information gain. Okay. So with the help of that, we will check for first case, second case, third case, and we will find out for second case it is more, then we will again reduce it, or if prune it. So in this way I will find one final rule. Okay. So first step is grow one rule. Okay. Now building a rule set. Use sequential covering algorithm. What will it do? Find the best rule which will cover the current state of positive examples. Yes, I have found. Eliminate both positive and negative examples covered by the rule. Yes, we have done that. Okay, each time a rule is added to the rule set, compute the new description length. Stop adding new rules when the new description length is d bits longer than the smallest. Okay, so this is of the theory. You don't have to give that much focus. You just should know how this Ripper algorithm works. So it has mainly two: growing a rule, how we will find one rule, and how we will make the rule set. Okay, maybe while growing the rule we are covering all the positive examples, but for negative also we have to add few rules. Okay, and if it can get pruned, then we will prune it. What is pruning? Like here you saw, right? These two cases were getting covered, but if we observed that if we remove these two, then also we will get the positive example with more efficiency, right? So this is how it will work. Now foils information gain. Okay, this is the metric. So actually it helps the in finding the support count of that rule. Okay, so let's suppose that there is a rule like this. Now it covers P0 number of positive examples. Okay, it covers P0 number of positive examples and N0 negative examples. Because we cannot say that at this moment this is a good one and only positive have been covered. But for that we will do the pruning, or maybe specific to general or general to specific. We will make it both specific, but at each phase we have to find points information again. So after we will, let's assume this was A. Now conjunct, one more condition. Okay, B is added. So now my rule has become A was already there, now B is there. Okay, now it is covering P1 positive examples and N1 negative examples. Okay, so with the help of this information, foils information gain rule can be extended like this: P1 into log base 2 P1 upon P1 plus N1. This is the new one, minus actually it is telling us the difference which we have got. As we know that this rule is proportional to, this particular measurement is proportional to P1 and P1 upon P1 plus N1. So it will always prefer the rules which will be having high support count and accuracy, right? So it got connected to that. Okay, so for this information here, let's assume that two rules are there. Okay. So for first rule I have got voice information gain as this, and for second rule I have got voice information gain as B. So I know this is better. Okay. Now if you want to do a pruning, the rule which we have got with the help of learn one rule function, it can be proved for improving their generalization error. Okay, so we will do For example, if with the help of pruning, if your error on the validation set is decreasing, then we will keep it. We should keep the simplified rule. Okay, so this is how we will do the pruning. Now, so at every step we will be performing this one, and whenever we will say that pruning is needed, or in that case we will be checking. How we will check? Yes, it is also important. Positive examples, negative examples. Okay, so we will check. Let's assume A, B, C, D. Let's assume with the help of this learn one rule function, I have got this rule. Okay. Now what will my refer algorithm do? It will check. I have to do the pruning, right? So I will check. What shall I do? Okay, let's prune this D first. It will always start from this direction. Okay. So I will prune this. So what do I get? I have got A, B, C, this. Now I will check the performance. If it is improved, then again what will I do? I will check with these two. So I will remove these. Now this time it has got worst. So I will say this is the final. But again I get this is get improved. Then I will add this one also. So again I will check the performance. Now if it has got better, I will say this is the final. But it is not better, then I will say this is the final. So in this way we will perform the pruning. Okay, so whenever we will be building the rule set, all the positive example, all the negative examples which are covered by any rule will be eliminated, so that new rules can be added to your rule set which will not be covering those records which have already been covered, so that your mutually exclusive condition is met. Maybe sometimes it can happen you have got one very simple rule and you have deleted the records also, but you have got one R4 which is for rest of the records, but few records which are covered by R1 are also covered. So in that case we will be adding priority, right? No, not a big deal. Indirect method. This is also very interesting. So indirect method, what does it do? This is a method for generating the rule from decision tree. Okay, so I know I am having one decision tree with me. Okay, so I have to find path from root node to the leaf node. Okay, so the path which is path defined from root node to the leaf node is will be expressed as one classification rule. And in the same way, we will be making rules which will be covering all of the leaf nodes. Okay, so if we will observe this example, here P is the root. Okay, now Q and R, these are the child, right? Now, if we will observe this rule set, let's check. If P is no, Q is no, then I have got negative. It is same, no problem. If P is no, Q is yes, it is positive. If P is yes, Q is no, R is no. If P is yes, R is no, then positive. If P is yes, R is yes, Q is no, negative. If P is yes, R is yes, Q is yes, then it is positive. But we can simplify these rules, right? Why are we making the rule this much complex? So for that, what we will do, we will be using C4.5. Okay, so I will show this, but before that, I will show. So, what was the rule number two? If P is no and Q is yes, then positive. What was rule number three? If P is yes, R is no, then positive. What was R5? If P is yes, R is yes, Q is yes, then positive. So I have taken, everything with positive result. Now, if you will observe this, then you will see that all these rules are predicting positive class. Now, if you will observe more, then you will find that if Q is yes here, then it is positive. Here Q is absent. Here also Q is yes, then is positive. I can say if anytime if Q is yes, then it is always positive. So I will make one rule, okay, which will state that if Q is yes, then it is always positive. Right? So if I will do this, what I can do, I can ignore this rule, right? And I can ignore this rule. So this is my new rule. And I have to keep this R3 same because there is nothing, no, like Q. Okay. So this is the resultant rule set. Okay. Uh, so this way we will make it more simplified because we are getting the specific ones. So how this C4.5 for indirect methods, C4.5 rules are used. So we will be extracting the rule from unpruned decision tree. You have extracted. Now for each and every rule, we will be considering one alternative. Okay, by removing one of the conjuncts, we will be comparing the error rate for that, and we will prune if error rate is less, and it will get repeating until unless we got all the pruned, what I can say, pruned ones. So here instead of ordering the rules, we are not ranking them. Okay, we are using the class based ordering, where first time I will be covering plus based and another time I will be covering the negative ones. So in this way you can use the indirect method. So what is the advantage of rule based classifier? It has a characteristic similar to the decision tree, highly expressive as a decision tree, easy to interpret. Yes, you have observed this. Okay, performance comparable to the decision tree. Okay, it is better suited for handling imbalanced classes and harder to handle missing values in the test set. So for that, maybe few more classifiers we will be discussing. Okay, so this was all about rule based classifier. Okay, next time we will be discussing nearest neighbor classifier. All right. Okay, thank you everyone. I'll rest my lecture here. Any doubt?
Hello,
Yes.
ma'am. I have been marked absent on 14th September.
14th September.
Yes, ma'am.
Actually, I have counted when how many presents are there. So according to that, I have given. So maybe you must have been absent somewhere, sometime.
Ma'am, on 4th, ma'am, I was present in all the classes. I also have written the
Okay,
notes.
I'll check my I will check my record, Karan. Okay.
Okay, ma'am.
Okay. Thank you,
Okay,
everyone.
ma'am.